Hello everyone, in this lesson we are going to continue our study of transformations. So in the previous lesson you learned how to do translations. In this lesson you're going to learn how to do reflections. Okay, and reflection is just a flip. So this is a transformation that flips a figure over a line of reflection. The image or new figure and the pre-image or old figure are reversed or mirrored. Okay. Uh, Each point is equidistant to the line of reflection. Now, equidistant is just a fancy term to say equal distance. So each point has to be the same distance from the line of reflection. Before I go into the examples here, let me give you a quick review. Okay, so I have sketched the y-axis and the x-axis. Okay, and let's say we have a line that crosses the x-axis at x equals 3. And I know it's hard for you to see, but this is purple. Okay, this line is purple. What is the equation of this line? Well, we see that this is just a vertical line and it crosses the x-axis at x equals 4. So the answer to this one is, since this has a slope that's undefined, the only value that matters is the value at which the line crosses the x-axis, and that will give you the equation. So the equation for this one is x equals 4. Okay, now let's say we have a line, but this will be a horizontal line, and this one crosses the y-axis at y equals 3. So if you're trying to find the equation of this line, what is the equation of it? Well, just look at where the line crosses the y-axis. It crosses the y-axis at y equals 3. So that's the equation of the line. Okay, so keep this in mind for the next example. So example number 1, part A. This is asking us to determine the line of reflection. To be able to do this, we are going to use this fact here that each point is equidistant to the line of reflection. And as you can see, we can't see the line right now, but if we count the distance from each corresponding point, okay, and as you can see, this one is barely noticeable, but this one has the prime or the hyphen, so that means this is the old figure, this is the new figure. So the distance from n prime to n is 1, 2, 3, 4, 5, 6. Okay, so that's at a distance of 6. And if you notice, this point E prime and E are going to be the same distance, also 6. So all we have to do is go back halfway. So 1, 2, and 3. I'm going to plot a point here, and it's going to be the same thing here. So once I have those 2 points, I can also do P and P prime, but I hope you realize that this point will be also halfway the distance between P and P prime. So once we see that, then we can sketch the line of reflection. Okay, and once we see the line of reflection, we just noticed where the line crosses the y-axis. So obviously this is the equation of this line is going to be not x equals but y equals, because it doesn't cross the x-axis, it crosses the y-axis at y equals 1. So if it's asking you to find the equation, then this is the equation of that line of reflection. Okay, and all we did was we counted the distance, okay, between the points. The next example, however, it's a little bit different. Okay, so notice that to go from this point to that point, I'm going up 1, 2. I'm going up 2, but then I have to go left the same distance, 1 and 2. So I'm going to plot a point here. Okay, and to go from L, I can't tell which is which, but let's say this is the new one and this is the old one. So to go from L to L prime, I'm going to go to the left 1, 2, 3, and then up 1, 2, 3. So notice I went left 3, up 3, so that means the same distance here. And if I go from V to V prime, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I should be able to go 9 here so I can plot a point. If that's not the case, then I wouldn't be able to plot a point here to help me sketch the line. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the same distance, which means there is a point. So I'm plotting these points because the line of reflection is going to pass through those 3 points. So once I have the points, I'm going to sketch the line, and this will make it easier to see where the line is going to be sketched. Now, as you can see, this line passes through the origin, and maybe you don't remember this, but from Algebra 1, this is the parent function of all the linear equations, okay, or linear functions. So this is the equation y equals x, has a rise of 1, a run of 1, and the slope is 1. All right, so keep this one in mind because we're going to use it again in a moment. Okay, so let's go on to example number 2. So this one is asking us to graph the image, and now we're given the equation of that line. So it's a reflection across x equals 1. X equals 1 means this is going to be a vertical line. Okay, so it's going to be like this one here. So next I'm going to look where x is equal to 1, and x is equal to 1 right here. So then once I plot that point, I'm going to sketch that line, and it's going to be a vertical line. So this is the line of reflection here, x equals 1. And then what I'm going to do is, since it's a reflection, each point is going to be the same, it's going to move the same distance across from the line of reflection. Okay, so these are the distance of 1, 2, then it's going to be the same distance on the opposite side of the line. So 1 and 2. So this is d prime. X is at a distance of 1, 2, 3, 4. 1, 2, 3, 4. So this is now x prime. And then t is at a distance of 1, 2, 3, 4. 1, 2, 3, and 4. So this is t prime. And then I'm going to connect the points to sketch the new figure with a reflection across the line x equals 1. All right. And all I did here was I counted or count equal distance, and notice that's what I've done with the last 3 examples. You count the distance and it has to be the same distance or equal distance. Okay. All right, let's go to the last 2 examples. So for example number 3, I'm going to give you a rule that's going to make it easier or easy to help you do these types of problems. So this is asking us to find the coordinates of the image with a reflection across the line, across the y-axis. So in this case, what happens is you're going to take the x coordinates and the y coordinates, and to the x coordinates, you are going to change the sign. But the y coordinates you are going to leave alone or as they are. So just pay attention to this, okay? So if I want to find the coordinates of k prime, to the x values, I'm going to change the sign. So it's going to be the opposite sign. This is positive 3. Now it's going to be negative 3. The y, I'm not going to do anything to the y. So this stays as negative 2. B prime, negative 4, I'm going to change the sign, it becomes positive 4. This is 1, so that stays as 1. And then J prime, this is negative 5, I'm going to change the sign, so it becomes positive 5, and this stays at 1 as 1. And the last point is R prime, this is positive 5, now changes to negative 5, and this one stays as negative 4. So that's all you do. Okay? All right, for the last example, there's another rule, and I can refer to example B on problem number 1. Okay, so let's do that. So watch what happened here. Let's just take one point. Okay, what are the coordinates of point H? The coordinates of point H are x is 0 and y is negative 2. Now watch, when you reflect this point across the line y equals x, this is the one that corresponds. So the value of x in this case is negative 2, and the value of y is 0. So see the difference? The x and the y values just flipped. And if you check this one here, L, let's say this is L, and that's L prime. So L has coordinates of -1, 1, 2, 3, 4, -1, and -4. And then L prime has coordinates of -1, 2, 3, 4, and -1. So this one is -4 and -1. And as you can see, they flipped. So guess what we have to do here with this problem? Because this is saying reflection across the line y equals x. So the rule for this one is you take the x and the y coordinates and you flip them. Okay, so xy, yx. So if we want to find the coordinates of j prime, all we have to do is flip these two values. So this is 1, -4. And for x, x prime is going to be 3, -2. And for p prime is going to be what? This is -2 and 1, and you're supposed to flip them. So this becomes 1 and -2. And that's all you do. All right, and for some reason this was blurry, but I hope you understood what I said. If not, I'll be able to help in the classroom anyways, okay? And if you're an online student, I mean, we can always schedule a Zoom meeting. All right, I'll talk to you guys soon. Thank you for watching, and I hope you copy all the notes, or make sure you copy all of these notes, okay? All right, bye-bye.